In that respect, the house actually and the whole remit of the solar decathlon competition is spot on. We need to address these things. We need to be more energy efficient, more sustainable. The ESTEEM house specifically is we're also looking at actually modern fabrication techniques. So, for instance, that wind catcher that will actually be 3D printed in concrete.
Good morning, everyone, and welcome back to another episode of Meet the Sponsors. And today we're here with Thornton Tomasetti.
Before we start the interview, here's a quick introduction to Team ESTEEM and our aims.
Team ESTEEM from Heriot-Watt University are the only UK team who are finalists in the Solar Decathlon Middle East 2020. A team of over 60 students from all over the world collaborating across 12 sub-teams to design one solar-powered house of the future. We are challenging you to build a future to be proud of. Our home combines traditional Scottish and Middle Eastern architecture with modern technology to create a sustainable, energy-efficient housing solution for the future. Team ESTEEM, pride in where and how we live.
Thank you so much for being here with us today. Would you like to introduce yourself a little bit for the viewers?
I'm Jeroen Janssen. I'm an associate director in the London office at Thornton Tomasetti, and I'm specifically looking at CFD, wind simulations. That's why I've been brought on the project as well, and that's where I'm actually working quite closely with Peter.
Yep, I'm Peter McDonald. I'm based in the Edinburgh office of Thornton Tomasetti within the applied science practice. So this was a nice exercise for us to apply our skill set to something a bit different.
That's interesting. So what did you major in university?
I did an undergraduate degree at the University of Aberdeen, and then I did a PhD at Heriot-Watt in theoretical physics. And then after that, I did a short postdoc at Heriot-Watt, and then I came to Thornton Tomasetti, where I've been since.
I'm slightly different in that respect. So I studied architecture in the Netherlands, in Eindhoven University. And from that, and that's when I got interested in the whole computational design, parametric design. And I've done a postgraduate course in London. And that was specifically focusing on kind of self-organizing systems. How can we link the whole parametric design with biological phenomena and even actually apply that? From that, I actually landed in a structural engineering firm. And last year, I made the switch to the computational team within Thornton Tomasetti.
Did you see yourself ending up in doing the work you're doing right now?
No, and that's quite interesting. The education in Eindhoven specifically, let's say, was really broad, right? First year is the whole construction industry, and then you gradually specialize. I ended up in architecture, and in the first year, I was thinking, well, structural engineering and building physics, right? These courses, I'm just getting through them to get them passed. But yeah, but then interestingly, because of that actually broad base in the education, I find myself now much easier to actually talk all the languages of all the consultants and all the specialisms in the firm. So it's interesting. No, I did not see myself here, but actually in hindsight, looking back at it, the education definitely helped.
Mm-hmm.
Yeah, I guess I did not see myself working for an engineering company. I was doing semiconductor physics, so couldn't be any further apart than looking at wind on buildings. I think definitely I learned that the skills you learn were broadly applicable. So yeah.
So fast forward to where you're working right now. What do each of you do day to day?
I'll start off with that. It's an interesting question because it varies a lot, actually. On one hand, I'm quite connected to actual project work, so actually delivering buildings with the structures group or with the facades group. So, for instance, I'm working on a big, it's actually an esports arena, so an indoor venue, and really in a 3D model, collaborating and getting the geometry right first, because this is quite a complex geometrical project. And then from there, actually in-house with our engineers, building up structural models. So that's one area. The other area within Core Studio is actually application development. So actually building those apps that convert stuff from a software to a software, that interoperability to also going from Rhino into SAP and back, and then also into Revit in terms of drawing documentation, let's say. Then the other part is really related to CFD and wind studies, which again has that same split. which has a split in terms of actual project work, but as well, we're doing some research and application development on that part to actually make that workflow smooth and automated. So we're actually building a couple of apps for that at the moment. And that's actually where we used and prototype the solar decathlon house as well in that workflow.
Do you typically use your own apps, or do you use more of the ones that are the softwares that are already there?
We try to use the best tool there is for the job. And if that tool doesn't exist, we'll build it ourselves. The thing is, with engineering software or so, validation is key as well, right? You need to know what the software does and where it tips over, it fails. The big commercial softwares, they all come with their validation. And also on the other side, the Revit, for instance, that is just through the industry, a big software where you communicate with. So we build our own tools, but also we build our own interoperability tools so that it doesn't matter which software we work in, but we can exchange it in any software which works externally as well.
That's cool.
So I guess a little bit different than Jeroen's applied science. What we typically do is we take structures. So that can be a wide range of things, like buildings, it could be something in the defense industry, anything that is a structure, anything that exists as an object. And we typically look at how these structures respond to extreme loads. So that might be anything from a bomb going off, strong wind, extreme heat, anything like that. So day to day, typically we're building models of these structures in-house. So that might be finite element models, computational fluid dynamics models, and then we'll apply either the loading the client has asked us to apply, or we'll derive the loading ourselves from some computational fluid dynamics analysis or engineering judgment. And we'll do some high-end analysis, and then we'll use our engineering judgment to provide solutions to our client. We do have other parts in this office that do actual physical testing, and so a big part of the work is correlating the physical tests, and that's something I think our clients really appreciate, that we can show this validation.
Mm-hmm. Bringing it to ESTEEM. So, what exactly has been your contribution to the Solar Decathlon House?
Yeah, so I guess we were really focused 2 areas. One was the external airflow around the building, so particularly around the wind catcher, which is the solar chimney type thing. And the other part was looking at the wind catcher, which is also meant to act as a solar chimney when the wind isn't blowing. If we could do a simulation of that to see if it actually acts like a solar chimney. For that, we were doing a CFD analysis where we looked at the solar radiation that was impinging onto the concrete of the solar chimney, how that heated up the mass of the concrete, how it heated up the air inside the chimney, or vice versa not, and how that induced a kind of a flow of air up through the solar chimney and what that would do to the flow around the building. So that was quite interesting. That's something that maybe was a little bit different for me in particular, looking at quite an intricate modeling of quite a unique shaped object. We got something that worked quite nicely in the end.
Yeah, wind with solar analysis. I've also looked at specifically wind and how actually could the wind catcher, so grab the wind at the top, draw it in, and actually bring it out into the courtyard, and lowering the temperature a little bit. So we've done a few simulations on different angles of wind attack, let's say. And we did see some actual turbulence and wind increase in that courtyard, so that's good. And we tried a few other things to make it more pronounced, let's say, to close off the courtyard so that the wind catcher is the only way in almost. That's also kind of where we want to use our tools, let's say. And that's where this was a nice collaboration with you guys, with students, really we want to use these tools, these CFD tools. Often the wind tools, they come in quite late in the process, right? It's like the design is done and we'll do a test on how the wind flows around the building, and okay, yeah, it's good, or it's bad, and we stick a canopy up or we stick a screen up, right? To resolve that specific corner. But actually, by working directly into the early design 3D CAD models, you can actually test some iterations quite early and actually adjust the shape of a building if you have to or need to. So I think that was quite interesting in this one, that collaboration.
So why did you decide to collaborate with Team ESTEEM?
In that regard, we're only part of a team. This is actually a bigger collaboration between Peter's office director and the team locally in Edinburgh and our office in Dubai. Basically, that collaboration was ongoing, right? And then Peter and myself got brought on board because there was the specific question of collaborating on the wind catcher and some CFD analysis.
Thornton Tomasetti saw kind of a useful partnership here because we have an office in Dubai. Heriot-Watt has campuses in both Edinburgh and Dubai. We're a structural engineering company, and as well, I think there are a few other things that Heriot-Watt and Thornton Tomasetti have in common. So I think it was decided that we would be more than happy to help contribute, especially to support our local universities. And yeah, I think there's been some additional collaboration besides Jerome and ourselves with Nick Misselbrook and Kyle Cray in Dubai.
And actually, to add to that, in general, I think at Thornton Tomasetti, we really have a model of trying to work with academic institutions, let's say, right, to actually build long-lasting relationships. Really, like it's not just a one-off, but actually, continuous collaboration back and forth. So whether it's in the form of the ESTEEM house, or some teaching, some courses, or PhD research back and forth, but we do work with quite a few of the top research institutions worldwide, really, I have to say.
All right. So maybe it's better if I ask you specifically, how has your experience been with the team, just with what you have been doing?
I think it was pretty good, actually. We had a couple of workshops, again, specifically on the Windcatcher, of course. So it was, I think, only a sub-team, but it was still like 6 or 8 people on the call every time, which was great to see, actually.
I must say, coming from a different background, so I'm not coming from a construction background, I always find it fascinating when I see a team coming together and building an entire house, and they each have their part, but they're all working together as quite a well-developed team, and they develop this thing which is pretty amazing, actually. I struggle to do basic DIY in my house, if I'm honest. So being in a team where they're developing a fully fledged net zero house is inspiring and very impressive.
I'm also curious to see how it goes now, let's say, with the whole delayed construction process. It was a great experience.
So I guess just drifting off from that a bit, what do you see the future of construction looking like? And do you think this house might affect that in any way?
Good question. And a big one to answer as well. The house and the whole solar decathlon competition is really spot on in the middle of this. I mean, obviously, global warming, sustainability, it's the big themes, carbon, net zero. That's all topics. We just don't have a choice anymore. It's not a discussion anymore that we can add that as a plus to our buildings. No, we have to address it. We have to deal with it. Global targets are set, etc. And even actually to meet those targets of net zero, we need to work way harder than we're currently doing. We actually need to hit those targets at 2030, because let's say if we design a project now, it takes 4 to 5 years it is completed, right? So actually, when that building needs to be operable, it needs to be designed 5 years ahead. So 5 years ahead, our design targets need to meet the net zero targets. And that's, I think, the discussion we need to have now, which probably has not been had enough. And I think in that respect, the house actually and the whole remit of the solar decathlon competition is spot on. We need to address these things. We need to be more energy efficient, more sustainable. And then actually, what I quite liked about the ESTEEM house specifically is we're also looking at actually modern fabrication techniques. So for instance, that wind catcher, that will actually be 3D printed in concrete, right? So actually the shape of that wind catcher, of that object, is sort of free form because of the possibilities of construction. And I think that's another way we need to push in harder. We're trying with Thornton Tomasetti quite a bit, a couple of different research projects happening at the moment. And one of them is 3D printing in concrete, which I think it's very promising, but it still also needs quite a lot of development. And that's where these research projects are quite amazing, actually, to kind of bring that to the next step.
I think bringing in analysis, this type of advanced analysis, so doing, this early stage wind CFD on your building, the coupled thermal and CFD analysis, looking at the wind catcher, I think that type of stuff is a lot of the tools that people are going to have to start adapting, very early on in their design in order to meet some of these goals, right? You have to get smarter about how you design things. So I think that was a really encouraging step to see, the future generation already embracing these tools. really early on. So no, really encouraged.
And as you mentioned, this is definitely a very important discussion to have. Have you faced any difficulties in your company, any challenges in achieving these future goals that we need to get to in 2030?
I actually think we're pushing quite hard as a company to be leading it, or at least be right at the forefront of these developments. We've actually developed a couple of tools. We've released Beacon, a plugin for inside of Revit that does embodied carbon takeoff, specifically for structural elements. We'll build that out for probably architectural elements as well. One of my colleagues, Duncan Cox, is part of LETI here in London, which is really looking at net zero carbon reductions within the built environment. There's quite a few of those similar initiatives back in the US, let's say. So I think we're pushing quite hard, and we're also, let's say, speaking up in the wider design teams, because often it's, as well as being pushing ourselves, we also need to educate clients, architects, MEP engineers, everyone, let's say, and because it's not us by itself, but it's the whole bigger design team of a big project, and pushing that into the right direction, let's say.
Absolutely. Okay, so just to close off, you have both mentioned a couple of projects that you've worked on in the past. Is there perhaps one project that stands out to you as one of the most interesting or challenging ones that you've worked on?
Good question. They're all different in a way. So I'm not sure if it's one to name, let's say. I think actually what we're trying to push now, I think with our CFD stands out for me, let's say. So we're actually trying to push, and we'll release some images and some videos of that pretty soon in the next few weeks. So we're actually trying to build this workflow. We call it a digital wind tunnel now as a working title, but we'll come up with a better name, let's say. But to really push the design of buildings, both from an external comfort view, but also from a structural view. So how can we very early in the design throw in a 3D model and get a very quick answer of structural loading on the building back? And that is really in the right ballpark, right? So it's early days, but it can also already tell us, do we need additional functions for a super tall building, let's say? Do we need dampers? Do we have problems with actually, not necessarily in terms of strength, but every building moves, right? So in terms of accelerations, how fast does it move? And is that actually perceivable by people inside of the building? And that's often a criteria that's governing actually the thicknesses of slabs, the width of columns, and etc. And can we identify that very early on, and then work in tandem with physical tests like the wind tunnel test, and actually gradually move through the process? And I think that's going to be quite if we really pull that off properly, it's going to be quite a change in how we design those buildings, I feel, with much more almost like scientific knowledge way at the beginning rather than late in the stage when the wind tunnel test comes back. And we're building that into this workflow, this app that we can deploy internally in our whole office. I think that's a big one. And that's actually what we're doing together with Peter at the moment.
Yeah, I was gonna say Snap. So I guess I've been working on this CFD for wind for the last probably 3 years in the background, just as part of Thornton Tomasetti's R&D initiative. Most of it has been focused on what we keep going back to is just doing validation. So there are a lot of, especially for architectural problems, there are a lot of actually nice validation problems you can do. And so, we've just been very carefully in the background going through these validation problems, making sure our software, our workflow gives us the right answer, and just trying to apply a lot of the knowledge that we gained in applied science, looking at other problem types into the architectural space. Yeah, that's been something we've been doing for a number of years. I think it's finally coming to fruition. We've expanded the team, so we have Core Studio with people from the structures department, from, applied science. Yeah, I think, hopefully soon we'll have some pretty exciting stuff to share with everybody.
That's definitely something that's really important. And in fact, I think that ties in with when we were talking about the future of construction, because I think if our design workflows start going in that way, it's definitely very helpful to think ahead to what our designs are going to be and really prepare for that. So that's definitely very interesting. Final question. Is there any message you would like to send to future graduates who might be joining the construction industry?
I think just in general, if you're a graduate and you have a degree in something, whether it be engineering or science or whatever, I think sometimes people feel like they're limited to that box. So if you're a mechanical engineer, you should be doing mechanical engineering type thing. I think the skills you learn at university, for the most part, are quite transferable. And if you have an interest in something, then you should pursue that. You should always take on board the best practices of the industry you want to join. Always be open to learning from your peers when you enter a new field. But I don't think you should feel limited to sticking to necessarily what you did when you started university, which frankly could be a long time, from when you actually enter the job market. So, flexibility, I think, is important.
I think that's actually a really good point. Also, looking back at myself, let's say, really starting with architecture and then being for quite a few years, first in another firm and now in Thornton Tomasetti, let's say as a structural firm, but then computational. So yes, I don't think it works in those silos. And the more and more the industry is developing, these silos and are breaking down. And actually, I think the interesting parts are when you're bridging over different fields of expertise and connecting the dots. So I guess in terms of message, it's probably stay curious and make sure after graduation, learning is not over. Like, I think it's the constant development that makes it interesting to move along, I think, and look into the future and grab these opportunities to kind of learn more about something, and then you can make that your specialism. Let's say, stay curious. I think that's my message.
Amazing. Thank you both so much for being here with us today. So that brings us to the end of the interview. Tune in next week for another episode of Meet the Sponsors. Thank you so much.
Thank you very much.
Thanks.